Get me?
Yes, sir.
Just a minute. Okay. So from 12 to 16th, I gave you as homework. Did you guys do it? Okay, tell me how to write the sample space. So coin is tossed. If the outcome is head, a die is thrown. If the die shows up an even number, then a die is thrown again. What is the sample space for the experiment? So if you get a tail, nothing is done, you will leave it. If head comes, then what is done?
H1 surface.
So 1, then
H2, then with 2, 6 times H2, 1 to H2, 6.
okay, then what we'll do is we'll first complete the odd numbers, H3, H5. Now comes the question, H2. If 2 comes, again H21, H23, H25. Similarly, H41, H43, H45. Then what will we do? H, if it is 2, and again a 2, again a 1. You're able to understand? H241. It can keep going on like this. Right? So this is again going to be an infinite set. Did you guys understand what I did? Yes or no?
Yes, understood, sir.
Okay, we'll go to the next one then. The numbers 1, 2, 3, and 4 are written separately on 4 slips of paper. The slips are put in a box and mixed thoroughly. A person draws 2 slips from the box, one after the other, without replacement. This is a very important case, okay? Without replacement. Describe the sample space for the experiment. Tell me. So let the 4 slips be S1, S2, S3, and S4. A person draws 2 slips from the box, one after the other. So S1, S2, or S2, S1 is possible. Similarly, S1, S3, S3, S1. Similarly, S1, S4, S4, S1. Guys, are you able to understand? So how many such outputs will come? Out of the 4, he's arranging 2 at a time. 4P2, not C2. Okay, it's not only choosing, it's in the order because without replacement. So 4P2 is how much?
12.
4 fact. It is 12. So you will have 12 outputs. S1, S2, S2, S1, S1, S3, S3, S1, S1, S4, S4, S1. Similarly, S2, S3, S3, S2, S2, S4, S4, S2. Then S3, S4. Do we have 12 here?
Yes,
1,
sir.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, 12 outputs are there. You understood how to find out that it is 12, like how your permutation and combinations is helping you. Right? So when will you use P? How will you know you're supposed to use P or C? In probability, you will be using P, when you come across the concept of without replacement. Had it been with replacement, it's more than without replacement. The important word is one after the other. When they say one after the other, the order is very important. Okay, next one. An experiment consists of rolling a die and then tossing a coin once if the number on the die is even. Okay, I'm read it again. An experiment consists of rolling a die and tossing a coin once if the number on the die is even. If the number on the die is odd, then the coin is tossed twice. Write the sample space for the experiment. So when you roll a die, you will get 1. If 1 comes out, what will, okay, let's first finish the even scenario. If 2 comes, what will he do?
Flip the coin. It will be 2H
Flip
or
the coin.
2H.
2H or 2T. Next.
4H, 4T, 6H, 6.
4H, 4T, 6H, 6T. If it is 1, then the coin is flipped twice. One head, one head tail, one tail head, one tail head, one tail tail. Then 3 head, 3 head tail, 3 tail head, 3 tail tail. Then 5 head, 5 head tail, 5 tail head, 5 tail tail. Right? So these are all the possible outputs. Next, a coin is tossed. If it shows a tail, we draw a ball from a box which contains 2 red and 3 black balls. If it shows head, then we throw a die. Find the sample space for the following experiment. S is equal to, tell me. So coin is tossed. If the coin shows a head, H1, H2, H3, H4, H5, H6. Yeah. So T, someone was telling, T means what will we do?
TR1, TR2,
That's right.
TB1,
T,
TB2,
TB2. That's it. Here we wrote it as B1, B2, B3 because they didn't say it's identical. They just told 3 black. That's it.
So if they say the balls are identical, like the black balls are identical and red balls are identical, it'll be only TR and TB, right? So
Yes, sir. That's what. Yesterday we did a problem, no? The identical white balls.
okay, sir.
Okay. Shall I move on to the next one? Next. A die is thrown repeatedly until a 6 comes up. What is the sample space for this experiment? This is again an infinite signal. If 6 comes, it is left. Then what will you have?
1, 2.
1 minute, guys. My device got stuck system now. Just a minute. 6. Yeah, then what will you get?
1, 6.
Here you need to use comma because you're dealing with numbers. 1, 6, 2, 6, 3, 6. It will go on till 6, 6. Then what is the other possibility? You can get 1, 1, 6, 1, 2, 6, 1, 3, 6. So you need to ensure whether you're writing an ordered pair, ordered triplet, or whatever it is, you need to ensure, you need to stop writing it when the last digit is 6. Right? So it is again an infinite set. Clear, guys? So with this exercise is over. Now we will go to the next part. Okay. Listen. So today we are going to discuss about the term events. Okay. So we are going to see what an event means. So till now we saw what a random experiment means and a sample space means. Right? And sample space means. So the sample space serves as a universal set for all questions concerned with the experiment. So till the 16th question which we did in the previous exercise, if you ask me, if you write the sample space, that sample space, since we are writing it in the form of a set, it represents the universal set of that particular experiment. So from that universal set, I can think of restricting my outputs by imparting certain conditions. Like what I can do is, if I take an example of tossing a coin, then if I ask you what is the sample space, head, 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 tail, head, and head, head. Look at the way I'm going to, tail. Look at the way I'm going to define the events. So this set contains all the possible outcomes. That is why I'm calling it as a universal set. From this, you can think of designing, you can think of taking the subset. So subset means, if suppose I'm writing even as head, head, by writing this, what is the statement you're going to give to it? So head, head is a mathematical notation. What is the statement you're going to give for it? So if I put a question, write the set of possibilities where you will get 2 heads. Then the set will contain only h, h. Suppose I write event E2 as head, tail. Then what is the name you can give for it? It is up to you. What are you able to observe? So this is an event where tail, where I can put it like this. Head on first throw and tail on second throw. Can I say it like this? Suppose I give E3 as T, T. What will you say? You can call this as either getting 2 tails or no heads. Both mean same. Guys, are you able to understand? Are you with me? Are you able to understand?
Yes, sir.
So all these subsets that you have taken, it need not be only one subset. It can be anything. For example, if I define an event like this, E4 as getting only one tail, then you can write head, tail, head. This is the subset of the universal set, which is the sample space, right? So all these subsets are what are called as events of the sample space. So these are called as the events of that particular experiment. So the occurrence of this happening is what is called as an event. Guys, are you able to understand? So description of events, and let's see how to write the subsets for them. Suppose the question says number of tails is exactly 2. Then how will you write the set? You will write it as T comma T. It's not comma T, it's TT. Suppose they say, okay, I'll do one thing. I'll blur it completely. Okay. Now we will try to write it. So number of tails is exactly 2. It will be TT. Number of tails is at least 1. At least 1 means it can be either 1 or 2 also. So what will be the events you will take into consideration? Tail head, head tail. Is that all?
Tail, sir.
You can write tail also because they didn't say at most. They told at least. The next one is at most. At most 1 head. So head tail, tail head. So write down the subset for where the second toss is not head. So second toss is not head means head tail, tail tail. Is that right? Number of tails is at most 2. Wait. I made a mistake. So when they say number of heads is at most 2, what should have been the answer? Guys, try. When they say number of heads is at most 1,
Head, tail, and tail head, sir. Only 2.
it is head, tail head. When they say at most 1, it can be 0 also. Means tail can also be taken. Okay. At most means minimum is 0, maximum is 1. At least means minimum is 1, maximum is 2.
Okay, sir. Understood.
Okay. Similarly, tell me number of tails is at most 2. Head,
All
head
4,
tail.
sir.
Yes, all the 4. Number of tails is more than 2.
None, sir.
It's null set.
Z.
Okay. So you can ask me how these are actually useful to us. So how it is useful is, okay, I'll slowly teach you how the definition of probability actually comes in terms of events and sample space. I'll slowly come to it, okay? So mathematically, any subset E of a sample space S is what is called as an event. Are you guys clear with this? All right?
Yes, sir.
So here we can talk about the occurrence of an event or non-occurrence of event. Let's see what it means. So consider the experiment of throwing a die. Let E denote the event number less than 4 appears. Okay, denotes the event, a number less than 4 appears. If actually 1 had appeared on the die, then we say that the event E has occurred. Similarly, if 2 or 3 has occurred also, we can say that the event has occurred. If suppose the output comes as 5, then what will you call it as? It is called as non-occurrence of the event. Okay, because what is the condition they have imposed? A number less than 4 means you can only get 1, 2 or 3 as the output. Not even 4 is accepted. Okay. So from this mathematically what we will say is, thus the event, see generally event is represented with capital E, sample space is represented with capital S. Because we know that the name of a set is represented with capital in the uppercase, right? So an event E of the sample space S is said to have occurred if the outcome omega of the experiment is such that omega belongs to the event E. If the outcome omega is such that omega does not belong to event, then we say that the event has not occurred. Okay. So depending on the occurrence of events, we are going to see what are the types of events that we have. So events are basically classified into various types on the basis of the elements they have. First is impossible and sure event. Okay. So impossible and sure event. When I say impossible event, it is not possible, right? Means the output will be a null set.
Null
When I
set.
say it's a sure event, it will be the sample space. Okay. The empty set null phi and the sample space S describe the events. So in fact, phi is called as the impossible event because there is no outcome possible at all. For example, in this case, number of tails is more than 2. I can call it as an impossible event. You can never get more than 2. Similarly, number of tails is at most 2. Number of tails is at most 2 can be called as a sure event because this event is equal to the sample space. So if I put a question like this, what is the probability of an impossible event? What will you say?
0, sir.
It is 0 because there is no output at all. Similarly, if I ask what is the probability of a sure event,
1.
it is 1. Okay, so that's the first thing that we have. The example part, everything you can read. I will go with the example of the head and tail, the tossing of 2 coins. Okay. Next is the concept of simple event. So if an event E has only one sample point, means only one output is taken into consideration, then we call that event as a simple event. So you guys tell me, out of all the outputs that I've written here, which is a simple event? I've written it here also. So listen, I'll ask you. 2 heads. Is it a simple event? So simple event should have only one sample point. You know what is a sample point? All the elements of the sample space are called as sample points. So head. Is it a simple event or a compound event? Are you still not able to understand? It's a simple event because there is only one sample point, H. Whereas tail head has more than one sample point. So it is a compound event.
Compound event.
I have doubts, sir. So tail head has only 2 sample points, no, sir?
Tail, yes, it has 2 sample points.
One
See,
head and one tail.
No. Tail is one sample point, tail head is one sample point. See, in the set you're separating the elements by a comma, right? This H is completely treated as one element. Just because you have 2H, you should not take it as 2 events, 2 sample points. It is one sample point only.
If it's head and tail, it would be 2 sample points.
Yes, it is 2 sample points.
Sir, and E2 is simple event, sir.
Yes, E2 is a simple event because head on first row, tail. So E2 is a simple event, E3 is a simple event. Number of tails is exactly 2 is a simple event. So except that everything else is a compound event. So that's what the example says. Now concentrate. In a sample space containing of n distinct elements, there are exactly n sample points or sample events. For example, in the experiment of tossing 2 coins, head, tail head, and tail, it has 4 sample points. Okay. So if you take only one sample point, then you can. So the number of sample points you have will define the number of simple events. The other name for simple is elementary. So why we call it as simple is because it's one of the outputs. That's it. That's why we call it as a simple event. Then what will be the opposite of it? It's a compound event. If an event has more than one sample point, then it is called as a compound event. For example, we can take the previous example itself. So by now you should have understood. Is this a simple event or a compound event? This one, tail, head, tail, tail. Is it a simple or a compound event?
Compound event.
A compound event because you have more than one sample points. Okay. So that's what the example is. For example, in the experiment of tossing 3 coins, event E is exactly one head appeared. So when you see, when you toss 3 coins, you will have 8 sample points, right? Head, tail, 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 head, tail, tail, head, tail, tail, head, tail, head, tail, head, tail, head, tail. So event E is exactly one head appears. So where is exactly one head appearing? One minute. Head, tail, tail. Okay. So where is it exactly one head that is appearing?
Head, tail,
Head,
tail.
tail,
Tail,
tail.
head.
So these are the 3 events. So these 3 sample points put together in a set is what is event E. So event E is a compound event in this case. Similarly, depending on the question, you can write it. No, at least one head appeared. At least one head appeared means 1 or maximum 2 is also possible. When you see the word at least means start with the number. At least 1. So start with 1. Maximum can be 2 or 3 also. So except tail, you will write everything. So you will have how many? From 8, one sample point is dropped. So you will have 7. 1, 2, 3, 4, 5, 6, 7. Okay. See, all these are important points. Okay. Concentrate. G is at most one head. At most means you can either have 0 heads or 1 head. So to the exactly one head appeared, there will be 0 heads also. That is tail, tail, tail. If you observe event E and G, what is the difference? It is only one sample point that is difference. That is TTT. Right? So these are all the types of events. The next is algebra of events. Like how we did the intersection and the union operations in sets. Here also we'll be doing some operations. Let's see what they are. So in the chapter on sets, we have defined different ways of combining 2 or more sets, that is union, intersection, different complement of a set. Likewise, we can combine 2 or more events by using the analogous set notations. Let A, B, C be events associated with an experiment whose sample space is S. So from a sample space S, we are randomly taking 3 events which are given by the name A, B, and C. With that example, we are going to understand. Okay. See, first is complementary event. If you have an event A, for every event A, there corresponds another event which is called as A dash or A prime. Okay, which is called as the complementary event of A. Okay, which is also called as not A. If you're a computer science student, you will understand what does not A means when you learn the logics. Okay, so if an event is occurred, okay, I'll speak in terms of occurrence of event. If I say A is an event of occurrence, then A dash is an event of non-occurrence. For example, I'll put a very simple coin. If I toss a coin, the outputs of a sample space are S. So from the sample space, I'm defining an event A as getting hit. Okay. Then what will A dash be?
Getting tail.
That is not getting hit. Right? Which is obviously getting a tail. You're able to understand? So this is what is called as complementary of an event. Let's see an example. So let's take the experiment of tossing 3 coins and associate an associated sample spaces, all the 8 elements, 1, 2, 3, 4, 5, 6, 7, 8. Okay. From this, we are defining an event A, which is head, tail, head, tail, and tail, head. It is the event where only one tail appears. Okay. So, what are all the sample points that are dropped? What are the sample points that are dropped?
Head.
So, 5 are dropped, right? So, what I'm trying to say is, if I take this as the sample point, see, I'm explaining in terms of set. Okay. If I take S as the universal set and A as the event, okay, if I take A as the event, what are all the sample points that are there within the event A? Head, tail, head, tail,
Tail, head.
tail, head. Remaining things are outside, right? Where are they? They are scattered somewhere in the universal set only. That is head, tail, head, tail, and tail. All the 5 are there. Okay. All these 5, can I write them as S minus A? That is the difference between the universal set and the set A. And that is what is called A complement. Guys, are you able to visualize in terms of set also?
It's the same as complement set, sir.
It's the same thing, complementary set. It's the same as complementary set, but I'm going to explain you some operations on probability. That time you will need all these Venn diagrams.
Okay, sir.
That is where I started. Yeah. So it is S minus A. See, all these notations you need not worry much because it's the same like what you have learned in set. Next is, if I have a sample space, from a sample space, I'm taking 2 events. Okay, what are the 2 events? I'm taking an event A and event B. So the operation that I'm going to do between these 2 events is, I'm going to call the operation between A and B as A or B, and that will be another output. Okay. So wherever you see this word or, okay, wherever you see this word or, it means union. Union is another meaning of addition. Right? So the meaning of it is, if I have an event A as getting 2 heads, if I have an event B of getting 2 tails, I'm just taking a random example. These are the 2 sample points that have come from tossing of 2 coins. If I ask you what is the event A or B, what will you write?
Head and tail.
You will write it as head and tail. That is the meaning. That is A union B. Union means or. Okay. So when set A and B are 2 events associated with the sample space, then A union B is the event either A or B or both. This event A union B is called as A or B, and that's the operation. Similarly, the next event that we are going to have is A and B. And means?
Intersection.
That is, you will take the common points. And is intersection. So we know that intersection of 2 sets, A intersection B, is a set of those elements which are common in both A and is the keyword here. That is, which belongs to both A and B. It is put between the inverted commas because of the term and. Okay, let's take example. For example, in the experiment of throwing a die twice. So when you throw a die twice, so throwing a die twice is the same as rolling 2 dice at the same time. So how many outputs you will have? 6 power
2.
That is, you will have 36 outputs. Out of those 36, so sample space, that is a universal set, contains 36 elements in it. 36 ordered pairs. From this, I'm trying to define an event A. So how is it defined? So they'll always give you a statement. Score on the first row is 6. Event B is the sum of the two scores is at least 11. Then how will you write event A as? Event A should be ensured that 6 is there on the first row. So 6-1, 6-2, 6-3, 6-4, 6-5, 6-6 will be the event A. Then what about B? B is the event such that the sum of the two scores is at least 11. At least means minimum 11, maximum
More 12.
maximum is 12 only, because 6 and 6 is the numbers that can appear, right? So 11 means you can think of 5, 6 and 6, 5. They both are different. So 5, 6 and 6, 5 will give you 11 and 6, 6 will give you 12. Okay. Then if I ask you what is A intersection B? A intersection B mathematically means you will take the common elements between both. So what are the common elements you are able to see? 6, 5 and 6, 6. Okay. Are you guys able to understand 6, 5, 6, 6? But let's try to put it in a statement and see. So 6, 5 and 6, 6 represents the combined event. And what does it state? The combined event of A and B states that the score on the first die is 6 and the sum of the scores is at least 11. And means you're taking both these events, you're taking out all these things and putting an end between them. Am I right, guys? Are you able to understand?
Yes, sir.
Okay. The next operation is event A but not B. So event A should happen, but B should not happen. B should not happen means B complement. And both of these things should happen simultaneously. That is by intersection. So wherever you see the question stating that event A but not B means A and B not. That is A and B dash. And means intersection. So we know that the set of elements from A minus B, which are in A but not in B, therefore the set A minus B may denote the event A but not B, but A minus B can also be written as A intersection B dash. Okay, they both mean the same according to set. Guys, am I clear till this point? Is there any doubt?
No, sir.
No doubts.
Okay. Okay, then we'll proceed with the problems. Just a minute. .2. Let me check if there is any theory part. Okay. You have these exhaustive events and all those things, exhaustive, independent, and all those things. I will explain what they are. Yes. So, first, let's do this problem. So consider the experiment of rolling a die. So as soon as you see rolling a die, write down the sample space 1, 2, 3, 4, 5, 6. Okay, now we will read the remaining part of the question. Let A be the event of getting a prime number. So what will event A contain?
2, 3, 5.
2, 3, 5. Event B will contain getting an odd number. 1, 3,
1,
5.
3, 5.
Write the sets representing the events A or B. A or B is A union B. What is it? 1, 2, 3, 5. Write down the set which contains A and B. A and B means A intersection.
Intersection.
So
3
it
and
is
5.
3. Yes. A but not B. A but not B. That is A intersection. So A intersection B dash means, so what is B dash, guys? 2, 3 and, sorry, 2, 4 and 6. Or I can say whatever is there in A which is not there in B. So what is A intersection B dash? What is common, guys?
2, sir.
It is not 1, it is 2. Similarly, A dash.
1, 4.
1, 1, 4, 6.
Are you clear? So that's all about these basic operations. Okay. Next comes two important types of events where they are called as mutually exclusive and exhaustive events. Okay. So let's try to understand what they are. Let's take an example itself. So in the experiment of rolling a die, the sample space is 1, 2, 3, 4, 5, 6. So consider the event A as an odd number appears. Event B is even number appears. Okay. If there is nothing common between the two events, I'm repeating it. If there is nothing common between the events that you have considered, it need not be only two, it can be more than two also. But for a beginning, we'll see with that. Here we have considered two events, A and B. If nothing is common between them, means when will nothing be common between them? That is when their intersection is a null set. When nothing is common between A and B, then the events A and B are said to be mutually exclusive events. Clear, guys? So when you write the event A in the set form, it is 1, 3, 5. Event B is 2, 4, 6. If I take the intersection between them, mathematically it is a null set. So A and B are said to be disjoint sets. So if there is nothing common between the two events that we have considered, then those two sets are said to be mutually exclusive events. Now I will give you an example. You guys tell me A, B. A, B. 1. So case 1 and case 2, which are the sets of mutually exclusive events?
2, sir.
2, sir.
Means there is no common. They should be disjoint sets. Means they should not meet at all. That is a meaning. Okay. So in general, two events A and set B are said to be mutually exclusive events if the occurrence of one of them excludes the occurrence of another event. That is a more technical way of defining it. But I'm putting it in a simple term. If nothing is common between the two events, then they are mutually exclusive. That is, they cannot occur simultaneously. In this case, the set A and B are disjoint. Okay. So again, in the experiment of rolling a die, consider the event A as odd number and event B as the number less than 4 appears. So event A will be what? 1, 3, 5. Event B will be 1, 2, 3. What is A intersection B? It is 3, 1 and 3. Which is
1 and 3.
So they are not mutually exclusive event sets because they are not disjoint sets. You have the space existing. I hope it is clear. So for mutually exclusive events, what is the operation we'll use? We'll use intersection. Similarly, we have something called as exhaustive events. If you see what is the basic meaning of exhaustive, see, for example, let's say you're running. Okay, I'm talking about the basic meaning. Let's say you're running on a track. Now your PT period, you're running. After some time, you get tired, right? You say you're exhausted. So what is the meaning of it? So you say you're exhausted. What is it you're exhausted? You have lost something. You have used the maximum of energy that is possible for you to play or run, whatever it is. The same is the case here. So if I give you two events, the events should be in such a way that if you take the elements from all those events, they should completely form the sample space. So if I have two events A and B. I'm starting with 2 again. It is not applicable only for 2. It can be for more than 2 also. If I take A and B as 2 events, and if I find the union between them, and if it comes out to be the sample space S, then A and B put together are called as exhaustive events. Am I clear, guys? Let's take an example. So when you take the example of rolling a die again, the sample space is 1, 2, 3, 4, 5, 6. You can define many events. See, you guys try know what are all the events you can define. You can try out whatever. So event A, you can define it like this, getting an odd number. Event B is getting an even number. Event C, you can define it like getting prime numbers. Event D is getting the numbers which are divisible by 3. Like this, how many events you can define? It's up to you, right? There is no limit for it. You can keep applying how many of the concepts you want. Right? So from that, the event A is like this. A number less than 4 appears. So event A is number less than 4 appears means it is 1, 2, 3.
1, 2, 3.
Event B is a number greater than 2 but less than 5 appears. So 3, 4. Event C, a number greater than 4 appears. That is 5, 6. Okay. Now tell me, if I find the union between A and B, what am I going to get? 1, 2, 3, 4. If I find the union between A and C, what am I going to get?
1, 2, 3, 5, 6.
1, 2, 3, 5, 6.
If I do the union, if I take the union between B and C, I'll get 3, 4, 5, 6. Now the question is, when I take the union between A and B, am I exhausting all the possibilities?
No, sir.
Because what is missing? I'm missing 5 and 6. Similarly, if I take the operation, the union operation between A and C, am I exhausting everything?
No, sir.
No. Because what is missing?
4.
4 is missing. If I take B and C, I'm missing 1 and 2. But if I take the union of all these together, then I'll have 1, 2, 3, 4, 5, 6. Is this not equal to sample space?
Yes.
Yes, sir.
Okay. So if you take A and B alone, you cannot call them as exhaustive events. A and C alone are not exhaustive. B and C alone are not exhaustive. But A, B, and C together are exhaustive. Guys, are you able to understand?
Yes, sir.
So here they have given you technical definition, at least occurs whenever the experiment is performed. All those things, keep it aside. You remember the simpler way of solving it. So this is the mathematical representation. So if you take the union between all the events that you have, and if that union gives you a sample space, yes, they are exhaustive events. Okay. So this is all this is all about the types of events. Okay. Now you are ready to solve problems. Actually, let's try that out. So 2 dice are thrown, and the sum of the numbers which come up on the dice are noted. Let us consider the following events associated with the experiment. So first, let me write the sample space 1, 1, 1, 2, 1, 3, so on till 1, 6, 2, 1, 2, 2, 2, 3, so on till 2, 6. Right? Now, what is event A? The sum is even. Remember, when you add two odd numbers or when you add two even numbers, the output will come out as even. So what are all the possibilities? 1, 1, 1, 3, 1, 5. Similarly, 2, 1, 2, 3, 2, 5. 3, 1, 3, 3, 3, 5. Then 4, 1, 4, 3, 4, 5. Then 5, 1, 5, 3, 5, 5. 6, 1, 6, 3, 6, 5. Is there any other possibility? We can think of 2, 2, 2, 4, 2, 6. Right? 4, 2, 4, 4, 4, 6. Then 6, 2, 6, 4, 6. Guys, is this
Sir,
right?
I have a doubt, sir.
Yeah, tell me.
Sir, they've given that the sum is even, so we have to add both the elements in the ordered pair, no, sir? It should be even, no, sir?
Yes, 1 plus 1 is even, no?
So then 4 plus 4 comma 1, can we write that, sir?
4, 1 will not come, no? 4. If you add an even and odd number, it will not be even, it will be odd.
Yeah, so then why have we included it in
Oh, did I
set
write?
A,
I'm
sir?
sorry. Oh, I'm sorry. This will not come. 4, 1 will not come. I'm sorry. 6, 1. Okay, this part will not be there. Now it is fine. Right? So both the numbers are supposed to be odd or both should be even. Thank you. Sorry, I missed it. So B is the sum is a multiple of 3. So what are all the possible outcomes? So when you talk about sum, what is the maximum sum that you can get from rolling 2 dice?
12.
12, right? So since they are saying divisible by 3, you can either get the sum as 3, you can get the sum as 6, you can get the sum as 9, or you can get the sum as 12. So what are all the possible outputs? 1 can be added to 2 or 2 can be added to 1. This will give you a 3. Is there any other possibilities? Next. So 2, 1 is there. Similarly, you can think of 2, 4 and so with 1, you can think of 2
1,
with 1.
1 comma.
Okay, but let's do one thing. We'll start with 1, okay? I'll tell you the order. 1 you added to 2, you'll get 3. 1 you added to 5, you'll get a 6. Right? Similarly, 2 you added to 1, you will get 3. 2 you added to 4, you'll get a 6. Then 3 you added to
6.
3 you added to 3, you'll get a 6. 3 you added to 9, you will get a 9. Sorry, 6 you will get a 9. Similarly, 4. When I say 4, 3 is eliminated. The sum of getting a 3 is eliminated. So 4, 2 is possible. And 4, 4 will not work. 4, 5. Yes, 4, 5 will work. Then 5. With 5, what can we do?
4, sir.
5, 1. 5, 4. 5, 1 will give you 6. 5, 4 will give you a 9. Similarly, with 6.
6, 3 and 6, 6. Sir.
We have written all the possibilities, right? Next. The sum is less than 4. So sum is less than 4 means it is possible only with 1 and 2, because if you use 3, the next number will be 1. So, slightly lengthy problem, but it's a good one. Tell me. Sum is less than 4, so it should not be equal to 4. If I start with 1, I can get 1, 1, 1, 2. That's it. 1, 3 is not possible.
Is it given equal to 4?
They didn't know. Sum is less than 4.
Okay, sir.
Okay, 2, 1. 2, 2 is not possible. 3 is not possible. So that's it. D. The sum is greater than 11. Sum is greater than 11 means 11 also should not be included. 5, 6, 6, 5 is also eliminated. So what will you get? Only
6,
possibility
6,6.
6,6. Now think, which of these events are mutually exclusive? So if I take A and B, are they exclusive?
No,
Even
sir.
if you find
No,
even if you
sir.
find one element common, it is not. A and B, 6,6 is there. When you take A and C,
No,
No,
sir.
sir.
if you take B and C,
No,
No,
sir.
sir.
C or D or A and B, sir?
A and D also it's not possible. A I have 6,6. So it should only
C
be
and D, sir.
C and D are exclusive, are mutually exclusive. Right? Does it make sense? So C and D are mutually exclusive. Let's check the answer once. Yes. So C and D are mutually exclusive. Right? Shall I proceed to the next one?
Yes, sir.
Now listen. So coin is tossed 3 times. Consider the following events. A, no head appears. So what is the output? Head, 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 tail, 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 head, head, tail, tail, head, head, tail, tail, head, tail, head, tail, head, tail, head, tail. Okay, that's the sample space. So event A is what? No head appears, means tail, tail, tail.
Tail, tail, tail.
Event B is exactly one head appears. See, this is different from at most one. Exactly one means there should only be one. So only
Head,
one
tail,
means
tail.
head, tail, tail. Go in the order. Yeah. Then
Tail,
tail, head,
head,
tail.
tail. Tail, tail, head.
That's right. And C is what? At least 2 heads. So at least is minimum 2, maximum 3.
Head, head, head.
Yes.
Head, head, tail.
Yes.
Head, tail, head.
Yes.
Tail, head, head. That's it.
That's it. So what are they asking? What do they want us to find? Do they form a set of mutually exclusive and exhaustive events? What about A and B?
They are mutually exclusive.
But not exhaustive. See, actually, the question, if I'm not wrong, they're asking about all the 3 sets put together, but I'm doing the individual analysis also for understanding. B and C are
Mutually exclusive.
but not exhaustive. What about A and C? They are also,
Mutually exclusive but not exhaustive.
but not exhaustive. What about A, B, and C put together? In A, B, and C, do they have any intersection point?
No, sir.
No, right? So they are mutually exclusive
And exhaust.
and exhaustive because you add them, no? You add the number of elements 1, 2, 3, 4, 5, 6, 7, 8. They are going to give you the sample space. A union B union C is equal to sample space. So they are exhaustive as well. Clear?
Yes, sir.
So we'll do one last problem and then the remaining we'll complete it tomorrow. Okay. A die is rolled. Let E be the event where the die shows 4. F be the event where die shows an even number. Are E and F mutually exclusive? Die is rolled. Sample spaces 1, 2, 3, 4, 5, and 6. Event E. Event E is what? Die shows 4. It is only 4. Event F is shows an even number 2, 4, 6. E intersection F is not equal to null set. So it's not mutually exclusive. Right? So the remaining problems we will do tomorrow and we'll complete it tomorrow. Okay. I hope there are no doubts.
No doubt, sir.